All right, so in this lesson, we are going to complete and write two-column proofs involving triangle congruence. So basically, we're going to show that two triangles are congruent using a two-column proof. We are actually, in order to do this, we're going to use the triangle congruent postulates. So we're going to use side, 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 angle, angle, side, angle, and angle, angle, side. So example 1 says that given that ray DB bisects AC, so ray DB bisects AC, and that segment DA is congruent to segment DC, we're going to prove that triangle ADB is congruent to triangle CDB. Before I go here, I like to just try to do it without writing stuff down, right? This is a good way of showing reasons, but it sometimes slows you down, and I don't know, it slows me down, and it kind of makes things more difficult sometimes. So I do it separately first. So we know that DB bisects AC. Okay, so we know that right there, that right there, AB is congruent to BC. So we know we got two sides that are the same. And we know that DA is congruent to DC. Segment DA is congruent to segment DC. We're good so far. And obviously, if we're talking about this triangle and this triangle, they share this side. So it looks like it's going to be side, side, side. So let's do this. DB, ray DB bisects segment AC. We know this because it was given. From there, we could conclude that segment AB was or is congruent to segment BC. Now that's because that's the definition of a bisector, is that it cuts it in half. So definition of bisector. So we've proven that two of the sides are congruent. We also know that DA, segment DA, is congruent to segment DC. We know this because it's given. So this is a side. We'll put it over here. And we know that this was another side. So we just need to prove that. They are, well, we just got to show that they have a third side that is the same, that has a third side that's congruent to the other third side. So it's kind of obvious because they use the same side length, right? So all you have to do is say that DB for this triangle is the same as DB for this triangle. So we just got to show that DB, segment DB, is, for this triangle, I guess, is congruent as DB for this triangle. So DB is congruent to DB. Sounds obvious, right? It is obvious. It's not. It's called the reflexive property. And so we proved that the last side was congruent. So we know that triangle ADB is congruent to triangle CDB because of the side, side to side postulates. Postulate meaning property, the side, side, side postulate, which means property, which means that if you have three sides of a triangle, then they're congruent. Those two triangles are congruent. So let's go to example 2. Given that PQ is parallel to SR and that PS is parallel to QR, prove that triangle PSR is congruent to RQP. Okay, cool. This one's going to be a little weirder, so I like to break this up. This is why I show it in this example. I'm going to draw actually PQ and SR. Well, part of it, right? I'm actually draw more like this. Now it says that they are parallel, PQ and SR. Right, so these are parallel lines. Now, if you look, I'm just going to extend these. Well, actually, I'm going to not extend these. If you look, we can pretend we're cutting it with like a transversal. So think about this as parallel lines. I want to put PQ here. And I'm going to put SR here. Oh, I know why it looks weird. Let me back up a little bit. It would look more normal if I were more like that. I stagger it a little bit. Here's P. Here's Q. Here's S. Here's R. These are parallel lines. I'm going to cut the parallel lines. Oops. I'm going to cut them one more time. Okay. I can do it. Okay, maybe not. I guess I'll just do it quickly. Okay, how many times? I don't know why I keep going the same weird like curve. Something must be. I'm gonna try it like this. Better, I guess. Okay. When you're cut by a transversal, don't forget that these two angles are the same. So I'm going to say that. I'm going to show you again. If I extend these two angles are the same. They are alternating interior angles. So I'm going to show it over here. Normally, y'all have seen parallel lines cut by a transversal like this, where you know that this one is congruent to this one, and this one. And you know, like the other ones are equivalent. So all I did was show you two parallel lines cut by a transversal. These are alternating because they're not on the same side. These are alternating interior angles. So I know that this one is the same as this one. Now I can do it the other way also though. If I know that this this angle right here is congruent to this this angle right here. So these are also alternate interior angles. So I'm going to back up. So I know that these two were the same, were congruent. Let me prove, and so I should know that. Let me see, so I did this one. And so these are the same. Oh, okay. So then there's also, actually I want to draw it like this. PS and Q R. So PS and QR. Remember that these were said to be parallel. And so we are going to cut them like this. Oh, here I go again. Okay, I'm going to, oh, success. So I want to extend these a little bit. So we know that this angle right here is congruent to this angle right here, because they are also alternating interior. Now the reason I'm showing you this is because this will come up. These will be the harder ones, like for you to see in your work today. But remember that anytime there are parallel lines and it looks like they're cut by something, you can find these angles that are congruent to each other. So let's say that PQ is parallel to SR. PQ is parallel to SR. This is given. And so because that they are parallel, we know that angle S, well, we'll say angle QPR, QPR is congruent, so QPR is congruent to SRP. And because these are alternate interior angles. Okay, let's see. Oh, we'll say, I guess we got to say definition of. Definition of alternate interior angles is that they are opposite and they are congruent. But we also know that SPR, oh, before we say that, we got to talk about, let's back up for a second. It's a little weird, right? We got this one right here from PQ and SR. We got this one right here, like these angles, from these parallel lines. So we have to establish that they are parallel before we can say that the alternate interior angles are congruent, or that they are alternate interior angles. So we know that PS is parallel to QR. We know this because it's also given. So because we know that PS is parallel to QR, and it's cut by this, we know that SPR, angle SPR is congruent SPR to QRP, angle QRP, because they are is also alternate interior angles. I can write that a little bit better. Alternate interior angles. Okay, so we established that two angles are the same. Oh, and they share another side. PR. So PR, segment PR is congruent to segment PR for the other one. This is just the reflexive property again. So we know that this angle and this side and this angle are congruent to, remember, the double side single. So double side single. So we know that these two triangles are congruent through angle, side, angle. So we know that triangle PSR is congruent to triangle RQP through angle, side, angle. Let me make sure that's a thing. Angle, side, angle. Cool. ASA postulates. And cool. That's it. Thank you.